The National Electrical Code, or NEC, allows for sizing the neutral service conductor the same size as the minimum service conductor. This is a common and acceptable practice. The minimum service conductor size is determined by the ampacity of the largest ungrounded conductor. Sizing the neutral the same ensures it can handle the maximum potential neutral current. It is true that service conductor size calculations account for fastened-in-place appliances and equipment that use a grounded conductor. Predicting future equipment additions precisely is challenging. By sizing the neutral service conductor equal to the minimum service conductor, you provide a safety margin for future load increases. If equipment additions cause the neutral conductor demand to exceed its capacity later, replacement might be necessary. However, this is typically only an issue with major expansions or remodels. The neutral conductor generally handles increased demand without problems. The NEC doesn't specifically mandate a neutral service conductor size larger than the minimum service conductor. However, local authorities having jurisdiction or ODGs may have stricter local regulations. It is crucial to consult your local AHA for specific requirements. Now, let's delve into the specifics of conductor sizing according to the NEC, focusing on Section 310.15b6 and related sections like 215.2, 220.22, and 230.42. These sections provide the framework for determining the appropriate size of conductors, considering factors such as the type of load, ambient temperature, and conductor insulation. The goal is to ensure that the conductors can safely carry the anticipated current without overheating, which could lead to insulation damage or even a fire. Section 310.15b6 specifically addresses the sizing of service and feeder conductors for dwelling units. It allows for a reduction in the size of the neutral conductor under certain conditions, provided that the requirements of other sections are met. This reduction is based on the understanding that in many dwelling units the neutral conductor does not carry the same amount of current as the ungrounded conductors. This is because some loads, such as lighting and electronic devices, draw current in a way that creates imbalances between the phases, resulting in a lower current in the neutral. However, it is crucial to carefully evaluate the load characteristics to ensure that the neutral conductor is adequately sized. Section 215.2 provides requirements for feeder conductors, which are the conductors that supply power from the service equipment to panel board or subpanel. It specifies that the feeder conductors must have an ampacity equal to or greater than the non-continuous load plus 125% of the continuous load. This ensures that the conductors can handle the sustained current draw of continuous loads without overheating. Section 220.22 addresses the calculation of the neutral load for feeders and services. It allows for a demand factor to be applied to the neutral load under certain conditions, recognizing that the neutral current is often less than the sum of the currents on the ungrounded conductors. However, it also specifies that the neutral conductor must be large enough to carry the maximum unbalanced load. Section 230.42 provides requirements for service entrance conductors, which are the conductors that bring power from the utility company to the service equipment. It specifies that the service entrance conductors must have an ampacity equal to or greater than the calculated load, based on the requirements of Article 220. It also includes specific requirements for the minimum size of service entrance conductors, depending on the type of installation. When sizing the neutral service conductor, it is essential to consider the potential for future load growth. As mentioned earlier, it is often difficult to predict exactly how much equipment will be added to a building in the future. Therefore, it is prudent to provide some headroom in the conductor size to accommodate potential increases in load. This can be achieved by sizing the neutral conductor the same size as the minimum service conductor, as this will ensure that it can handle the maximum possible neutral current. However, it is also important to consider the types of loads that are likely to be added in the future. If the building is expected to have a high proportion of nonlinear loads, such as electronic devices or LED lighting, then the neutral conductor may need to be sized larger to accommodate the harmonic currents that these loads can generate. Harmonic currents are currents that have frequencies that are multiples of the fundamental frequency of the power system, which is typically 60 Hz in the United States. These currents can cause overheating of the neutral conductor and other electrical equipment, so it is important to take them into account when sizing the neutral conductor. In addition to the NEC requirements, it is also important to check with your local AHJ to see if they have any specific requirements for the sizing of neutral conductors. Some AHJ may have local amendments to the NEC that require the neutral conductor to be sized larger than the minimum service conductor. It is always best to err on the side of caution and size the neutral conductor appropriately to ensure that it can safely carry the anticipated current. Remember, safety is paramount when working with electricity, and proper conductor sizing is a critical component of electrical safety. Now let's discuss some practical considerations for sizing the neutral conductor in different types of buildings. In residential buildings, the neutral conductor is typically sized the same as the ungrounded conductors, especially for small load services. This is because the loads in residential buildings are often relatively balanced, and the potential for future load growth is limited. However, in larger residential buildings, such as apartment buildings, it may be necessary to reduce the size of the neutral conductor, as allowed by the NEC. In commercial buildings, the neutral conductor sizing can be more complex, as the loads are often more diverse and the potential for future load growth is greater. It is important to carefully analyze the load characteristics of the building to determine the appropriate size of the neutral conductor. In industrial buildings, the neutral conductor sizing can be even more challenging, as the loads are often highly nonlinear and the potential for harmonic currents is significant. It is essential to use specialized software or consult with a qualified electrical engineer to determine the appropriate size of the neutral conductor in these types of buildings. Regardless of the type of building, it is always a good practice to document the calculations and assumptions that we use to size the neutral conductor. This documentation can be helpful in the future if there are any questions or concerns about the conductor sizing. It is also important to keep the documentation up to date as the building's electrical loads change over time. In summary, sizing the neutral service conductor is a critical aspect of electrical design and installation. It requires a thorough understanding of the NEC requirements, as well as the specific load characteristics of the building. By following the guidelines outlined in this narration and consulting with qualified professionals, you can ensure that the neutral conductor is adequately sized to safely carry the anticipated current and provide reliable electrical service. Always prioritize safety and adhere to all applicable codes and regulations. Remember to consult the latest edition of the National Electrical Code and any local amendments for the most up-to-date requirements. Electrical codes and standards are constantly evolving to reflect new technologies and best practices. Continuing education and professional development are essential for staying informed and ensuring the safety and reliability of electrical systems. Now, let's consider some specific scenarios and examples to further illustrate the principles of neutral conductor sizing. Suppose you are designing the electrical system for a small retail store. The store will have lighting, display cases, cash registers, and a small HVAC system. The total calculated load for the store is 50 amps per phase. According to the NEC, the minimum size service entrance conductors for this store would be number 6 American wire gauge copper conductors, assuming THHN insulation and a 75°C termination temperature. You could size the neutral conductor the same size as the ungrounded conductors, which would be number 6 American wire gauge copper. This would provide ample capacity for the neutral current and allow for future load growth. Alternatively, you could perform a neutral load calculation to determine if a smaller neutral conductor is permitted. If the neutral load calculation shows that the maximum balanced load is less than 50 amps, then you could use a smaller neutral conductor, such as number 8 American wire gauge copper. However, it is important to carefully consider the potential for future load growth before reducing the size of the neutral conductor. Now let's consider a different scenario. Suppose you are designing the electrical system for a large office building. The building will have lighting, computers, printers, copiers, and a large HVAC system. The total calculated load for the building is 400 amps per phase. In this case, it is essential to perform a neutral load calculation to determine the appropriate size of the neutral conductor. The neutral load calculation will take into account the types of loads in the building, the diversity of the loads, and the potential for harmonic currents. Based on the neutral load calculation, you may be able to reduce the size of the neutral conductor significantly. For example, if the neutral load calculation shows that the maximum balanced load is only 200 ohms, then you could use a number 3/0 American wire gauge copper conductor for the neutral. However, it is important to carefully consider the potential for future load growth and the impact of harmonic currents before reducing the size of the neutral conductor. In some cases, it may be necessary to install a separate neutral conductor for specific loads such as computer equipment or LED lighting. This can help to reduce the amount of harmonic current on the main neutral conductor and improve the overall performance of the electrical system. When installing a separate neutral conductor, it is important to ensure that it is properly sized and grounded. It is also important to label the neutral conductor clearly so that it can be easily identified in the future. In addition to the NEC requirements and the local AHJ requirements, it is also important to consider the recommendations of equipment manufacturers when sizing the neutral conductor. Some equipment manufacturers may have specific requirements for the size of the neutral conductor that must be followed to ensure proper operation of the equipment. For example, some manufacturers of uninterruptible power supplies, or UPSs, may require the neutral conductor to be sized larger than ungrounded conductors to handle the harmonic currents generated by the UPS. It is always a good practice to consult with the equipment manufacturer before sizing the neutral conductor for any sensitive electronic equipment. Finally, it is important to remember that the neutral conductor is a critical component of the electrical system and should be treated with the same care and respect as the ungrounded conductors. The neutral conductor provides a return path for current and helps to ensure the safety and reliability of the electrical system. When working with the neutral conductor, it is important to follow all applicable safety precautions and to use proper grounding techniques. It's also important to address the concerns regarding equipment added after the initial installation. If more equipment is added later and the neutral demand surpasses the existing conductor's capacity, replacement becomes necessary. However, routine additions generally don't necessitate this. In conclusion, let's revisit the key takeaways regarding neutral conductor sizing. Firstly, the NEC permits sizing the neutral service conductor the same as the minimum service conductor. Secondly, consider future load growth and potential harmonic currents when sizing the neutral conductor. Thirdly, consult with your local AHJ and equipment manufacturers for specific requirements and recommendations. Fourthly, always prioritize safety and follow all applicable codes and regulations. Fifthly, proper documentation of calculations and assumptions is crucial for future reference. By adhering to these principles, you can ensure the safe and reliable operation of electrical systems while complying with the National Electrical Code and local regulations.